Hello all, and welcome back to the second part of the mini lecture that we gave on symmetric modeling. The second part is going to be about the tool called symmetric modeling right here. Sometimes when you model, you want to take a more holistic approach to it and model across the symmetry plane. Although you may want it to be symmetrical after all. Remember the last lecture I told you that sometimes you only model half of it, but then you have to be really careful of what's happening across the symmetry plane. In this case, we are going to model across the symmetry plane on both sides of it, but making sure that we also keep the tangency and curvature across the symmetry plane. So what I'm going to do here is I'm going to throw up a curve on the back plane right here, and I'm going to do it across the XZ plane. So if I just bring on a CV curve and just roughly throw out some CV points here, you can clearly see that this would not be symmetrical over the XZ plane. But as I told you, there is a tool for it called Symmetric Modeling. We're going to use that in just 1 second. First of all, we need to, similar as to using symmetric modeling with layers, in this case also define the symmetry plane. So if I go back to the perspective view, you can all see what's going on here. And I go to Layer, Symmetry, Set Plane, and I get these 3 plane symbols here. Also, I can work with and rotate them and move them about and so on. So I can choose any of these black symbols right here. And in this case also, I would like the XZ plane to be our symmetry plane. So I pick that and I click Set Plane, like so. And if we then go back to the back view and watch what is happening here, I'm gonna pick this curve, like so, and hit Object Edit, Symmetric Modeling. Now pay close attention to, hold on 1 second, I'm going to bring this curve down slightly so you can all see what's happening here. When I hit Symmetric Modeling, pay close attention to what is happening to the CV points here. Bam, like that. It automatically adjusts the CV points on the other side of the symmetry plane. Note that the curve begins here. You can see that by this little U symbol here. So it will correct all the CV points on the other side of the starting point of the curve, on the other side of the symmetry plane, and make them symmetrical and keep them that way. So if I now start manipulating this curve, anything I do on this side will happen on this side as well, as you can see here. And it actually doesn't really matter which side I work on. So if I pick one on this side, it will work just fine. And the beauty of this now is that we are always guaranteed to keep a tangency and therefore also curvature over the symmetry plane. So I don't need to worry what is going on here. And that is a huge advantage. Now, what if I would use a curve of a higher degree? Or as you can see here, we have 1, 2, 3, 4 CV points, and meaning that this is a degree 3 curve. What if I would throw up a curve with, say, 5 CV points, like that? We have an odd number of CV points here. This is a degree 4 curve. I told you before that it will correct the CV points on the other side of the symmetry plane, counting from the starting point of the curve, which is here. It will also take the center CV point and set it exactly to the symmetry plane right here. So if I go Object Edit, Symmetric Modeling, oops, pick curve, Object Edit, Symmetric Modeling, it will also correct this CV right here, apart from these two. Now this is also symmetrical. So if I start working with the CVs here, you can see that the change is also reflected on the other side right here. If I try and move this CV, it works, but only up and down and in the X direction. If I go to the perspective view, I can show you that as well. If I try to move this up and down, it works. If I try to move it in the X direction, it also works. But if I try to move it in the Y direction, it is locked. So it will always stay on the symmetry plane. Now this also works for surfaces. And in the case I want to get rid of this symmetry condition of this curve, I simply pick the curve, go delete history, and once I've deleted the history, the symmetry condition is also removed. You can see what objects have the symmetry condition by picking them, and you see this little yellow plane symbol right here indicating that this is a symmetrical curve, while this one is not. So if we use this non-symmetrical curve, we could just deform it slightly like that, something like that. So it's no longer symmetrical. And if we then Control C, Control V, move it in the X direction and create a surface here. I'm going to go with skin as usual with crown on, so we get a nice shape of it, like so. Let's also get rid of the construction history for this surface. So, and also we could get rid of all the curves here. So, and if we now look at the CV points of this surface right here, it looks something like this. Now we need to observe which is the starting points of this surface, and you can see that by the indication of the U direction, which is right here. See if I can zoom in. See, there is a U here, which is the first direction of the surface. Also, you have a tiny little V here, indicating the second direction of the surface. This is then the starting side. And if I hit Object Edit, Symmetric Modeling, you notice that the other side is then affected. And this row here of CVs is locked to the XZ plane. So anything I do on this side will also be reflected on the other side, and you're guaranteed to keep the tangency and curvature across the symmetry plane. So good luck with your symmetric modeling. Thank you for listening. Bye-bye.